so deep dive into the core topic of this presentation. So some of you are AI leaders, some of you will become AI leaders, and currently AI leaders, they have many challenges on their plates, and I've selected some that I find interesting for the story I'm going to tell. The first, so AI leaders, they are challenged to accelerate the value creation based on AI. AI has been around for many years. In many companies, there are some teams for many years now that have been doing some POCs, some tests. They have even put in production some use cases, but the top management is expecting more and more and expecting to accelerate. And also because of the recent advent of GenAI and all the buzz around the potential it has, the possible miracles it can create, the top management is expecting AI leaders to accelerate on value creation. A sub-challenge, depending on the first, is that so AI leaders, they perpetually face this question of do we make or do we buy for each different verticals, across products, across IT system, across many different things. I believe that every one of us will have to deal with hybrid strategies where we both buy and both make. We can make everything we need to buy. And when we buy, we now have many options. We can buy end-to-end applications, or we can buy simple APIs that do core things, but we have to build around. We can buy SaaS solutions, or we can buy things we need to put on-premise. And for some reasons, sometimes we need to make because we need to do something for our core business. We need to adapt the solution to our specificities. We need the AI solution to bring value to one of our something that is a competing differentiator. Or we want to manage better the risk. We want to manage better the roadmap of the functionality. So many reasons, and usually when we do that, we leverage open source, of course, which is today something that helps us start from something really solid and manage to make solutions with acceptable costs. So when you decide to make some solutions, a sub-challenge is that, well, you want your solution to be to evolve with the fast-evolving AI environment. You want it to be future-proof, but still you need to have a solution that is matches the requirements, internal requirements in terms of industrialization, standardization, mutualization of the solution between teams, between verticals, and that is maintainable. So why is it is important that those solutions are future-proof? Let's have a quick look at the history of AI. So since the years 2000s to today, things have been accelerating. I'd start, so I take the example here of different verticals on unstructured data, so natural language processing, computer vision, speech-to-text. So there were solutions existing already, but that were a bit heavy to put in place, requiring handcrafted features and so on. Then came up the end of AI winter with some the deep learning models achieving great results, and they diffused in all verticals. Then in 2018, Google released and open source the transformer architecture, which had a big impact on the NLP space and then on other verticals. And now, of course, we all face the GenAI paradigm with again the transformers, but more GPT style and autoregressive generating models that are impacting once again all verticals. So here I only put only the main changes, the main paradigms changes, but in between, actually, there are many things that happen and more rapidly. Small evolutions that can impact the functionalities you can deliver to your business, to your client, to your internal client or external clients. So this is the first thing, is that it's really accelerating now. I think I don't need to convince you there. Fortunately, what happens is that we see some convergence in different verticals. So the types of models, the types of frameworks that help us, that offer us abstractions to more easily use models, they tend to converge. So it means also that when you decide to make on one of the verticals, it becomes, and if you decide to make on several verticals, it's more and more easy to have internal resources, collaborators that actually share a lot of skills and share a lot of competencies. So it's more easy to develop on several verticals. But so I showed you a lot of things around models here, but actually, it's not only models, it's not only deep learning architectures that change over time. And if you build an in-house system, there are many other things that your system should be robust to in terms of evolution. So the way tasks are actually modeled change. So here, so when I say task modeling, I actually mean the way mathematically you represent the task you want to accomplish. And I take the example in the NLP space where, for instance, Google with their T5 paper and T5 model family showed how you can model all classical subtasks in NLP, such as text classification, token classification, summarization, translation, Q&A, in one and same single format that is adapted to this new paradigm of generative AI and LLMs. So, but to do that, it means that the way you pre-process your input data and the way you post-process it must be adapted accordingly. The other thing that changes over time and continues to change is the data dependency, notably for the training part of, if your AI system is offering services on the training of models. Well, at some time, we faced the revolution of transfer learning, where so some models are pre-trained on massive data sets, and we needed to fine-tune them on different specific tasks on our custom data, on our enterprise data. Then came the concepts of zero-shot and few-shot learning, where you are actually able to make some models do some tasks they were never trained on before. And also came up the paradigm of context learning, where you can condition your model on some information you give it to him through, for instance, also RAG, so retrieval augmented generation, where you first retrieve the context you need from a database document database. And now there is also this concept of synthetic data generation, meaning that you have at your disposal now some models that are able to generate some data, maybe some data that is close to the data of your business domain, and that you can use to evaluate other models, or you can use to train other smaller models, for instance. Something new that appeared is this concept of prompting and instructing models. So, and in terms of AI system design, there's something interesting here. It means that you could decide to enable the users of your system to actually have more autonomy and decentralize what I call the AI model customization, because the user of your system, if you offer that to them, could actually, yes, inject some prompts. And it comes, of course, with a lot of challenges. Another thing that changed a lot over time is how you serve your models. And with bigger models, if you want to use some open source LLMs, for instance, you have this problematic of mutualizing the serving of those models, because they are very costly to host, but often those models, okay, they work well in zero-shot, but you still need to adapt them and maybe fine-tune them. So how you can do that efficiently, still mutualizing the foundation model, but having maybe something dynamic per request, where you use, for instance, this concept of adapters, where you add weights to the backbone of the model to adapt your model. Another thing that changes is evaluation methods, and so for unstructured outputs in the paradigm of generative AI, it requires new evaluation methods, new evaluation paradigms. So if your AI system was offering services on that, you need also to adapt on that. So in this ever-changing environment, how do you manage to build in-house AI systems that are future-proof? I'm going to take the example in our company of the intelligent document processing. And first, I'm going to give a bit more context of why it's important for us. So, as I said, we are an insurance company. And have in mind that an insurance company doesn't have that much frequent interaction with the customers. For instance, if we compare to retail banking, where you use your bank account every day, you maybe connect to it weekly, and you do a lot of operations. In the insurance context, usually we have interaction with our customers at subscription of the product, and when they have a problem and they want to use what the product is for, so when they need to open a claim. And those two touch points are filled with supporting documents. So for subscription process, we need we require some documents from our customers. For instance, for the subscription process, so ID documents, legal documents, medical reports, financial statements. And for the claim process, we also need to require some documents about to justify the problem that our customers have. And that can be an employment certificate, death certificates, police reports, experts reports, invoices. So for us, being excellent on document processing, we see it as a differentiating, as a competitive differentiator. Because it has impact on the customer journey satisfaction, because it can decrease operational costs, and remember that I told you we're a B2B2C insurance company, so we need also to have our partners happy, and if through very good customer journeys, we can also protect the brand image of our partners, that's really important for us. And as we are an insurance company, we also have to deal with some types of data that are very sensitive, sometimes secret data, medical data, and depending on your company's data protection governance, or depending also on the countries you operate on, sometimes you don't have any choice but to only consider on-premise solutions. So at BNP Paribas Cardif, our decision for this topic, as we have strong data protection requirements, was to work only with on-premise solutions, and as we wanted to be excellent at document processing, we decided to try to do it in-house. So I know some of you in the room might be a bit wondering why, because sometimes this subject is considered a commodity. So there are a lot of companies or services or that can do that really good, and why trying to do it in-house? Well, today we are happy we have done it in-house, because when we are benchmarking what we can do compared to external vendors that we can have on-premise, we do far better. And when we compare to solutions we don't have access to because they have data protection problems, we have comparative results. So just to be clear, what is intelligent document processing? It's about processing images, doing optical character recognition, recognize the type of document, extract some information, match some information with the systems we have, and also have this quality assessment. If you want to automate things, you have to really, actually, what you are doing is you are taking risk, maybe because it's AI, make errors, and you have to manage properly this risk of how much error you accept to make to create some value in terms of user experience and so on. And so for the solution I'm going to talk to you about, what we chose is to develop an in-house IDP solution that covers all this model lifecycle, let's say, from data annotation to data formatting, model training, business use case configuration, evaluation, reproducibility and traceability, and deployment and monitoring. I'm going to skip that one, but before I give some insights, I want also to come back to the history of IDP. So IDP, it's a mix of NLP computer vision technologies. Here you can see a brief history of different technologies that over the years that changed. And I would like to focus on one specific transition that we had to face and try to tell you why it was important for us to be able to do this transition with the system we built. And then I'll tell you later how we managed to do it softly thanks to some principles. But so here you can see that there's the first methodology that is composed of different bricks, different models that we have to orchestrate, to do what we need to do in IDP. And in 2021, we started to appear what we called end-to-end generative models. So end-to-end in the sense that there are models that actually take directly the image pixels as input and generate the outputs you want, so the information you need to extract. And those models, they don't need to do you don't need to do intermediary steps such as to do the OCR of the document. So it was really important for us to really quickly embed that in our product. Why? Because then you have only one model to train and maintain, so that's easier maintenance. It's also more rapid for the build phase of our project. It has enhanced capacities. It can handle some difficulties such as multitask to do both extraction and classification of the document. It can handle entity linking, so when you need to extract information that have a relation in the document, it can do that more easily. It can format directly the information from the document to a format that you're interested in. So enhanced capacities. And also, that's a big point, it's easier for the annotation phase. So you all know that when you want to train some models, you need supervised data. And for unstructured data, usually you need humans to first annotate. And for the former family, you needed actually to do heavy annotation where you need to take the image and draw bounding boxes around the information of interest. And with those type of models, you actually don't need to. You just need to write the text you want to extract. And what is magic is that if your information system already has a database of the documents and a database of the information that you're interested in and was in the document, you just need to extract the information. You don't need anymore to do some human annotation, and you can directly train those models from the information you extract from your history you have in your database. So it means that it has a lot of impact in the cost of building new use cases and deliver them in shorter times. So it was really important for us to be able to do that. And a second transition I mentioned that we are currently working on. Of course, there are now those huge models, those huge LLM models that are multimodal, that can that pretend to be able to do intelligent document processing with just in zero shot. So we are studying that with the constraints that I told you about before, that we need to do things on premise. And I'll show you some figures afterwards, some insights on that. But for us, it's not ready yet. We don't manage to have the same results we can have with what we built before with that type of approaches. Another message I wanted to say is that one paradigm you should not see one paradigm as replacing totally the other. and we'll see that again later, but it's really important to see that actually all those solutions, they can be combined or used as alternatives because they don't have the same profile in terms of the training data requirements. So I explained to you that between these two solutions. But they have different running costs, and they have different latency and quality trade-offs. This is a small slide showing some results, for instance, on so this transition where we are studying large language models and multimodal large language models. So here, those are results on open source large language models, multimodal large language models, and there are not only multimodal large language models. Often, multi-language large language models are trained to process images in a low resolution. And there are only few models in the market and on the open source part that are able also to process documents in enough resolution so that they can really deal with small characters and detailed information in document. And here we studied different state-of-the-art open source models. And you can see that, so on those two columns, it's open source data sets. And here you have the accuracy of the quality of the information extraction. So it's far from being 100%, okay? And on the internal case, it's far also to be really perfect. And with our in-house models, we have more like around 85% accuracy. So that's a big gap. And you see that those models, they are huge in terms of memory consumption. And so it's to elaborate on the fact that this transition for us, we are studying it, but it's not mature enough so as to answer our business challenges and what our internal teams and business units are requesting from us. Looking at the time, okay, so now I'm going to share with you some principles, 5 principles that I think helped us build something that is future-proof. Maybe some principles you will find obvious, maybe some not. I'd like you to share your comments afterwards on that. But the first principle that I think is really important is to decouple what I call IT parts and the AI parts in your AI system. So you see that the AI part has many reasons to change, okay? And when the AI part changes, the IT part should not change. Okay, the whole system, generally it's an IT system, so it needs to be architectured, validated by the IT teams in the organization. But the AI teams, the ones that have the expertise and knowledge about all those technical details about models, the capacity of models, they should require that they have a decoupling between two solutions so that they manage the evolution. So this is a macro diagram of a possible AI system. So you have the client application, and the AI system should be really divided with an IT part and an AI part with something that decouples the two. And what are the type of responsibilities I see in terms of segregation? The IT part, it should be the more stable possible. So you should put there all the things that won't change because AI changes. So the secured exposition of the service, temporary and permanent storage, the user interfaces, the orchestration of all those IT steps. And on the AI part, you should handle what is about pre-processing, post-processing the data, the orchestration of the AI steps if you have different steps, and of course, making the models evolve. And you have several solutions to decouple the two. I mentioned some, such as asynchronous messaging, but of course, those details have to be discussed internally and depending on your context. And I think the big error is to put some AI logic in the IT part. That's where you could actually face some costly refactoring if you want to transition or integrate a new paradigm. And maybe some of you think this principle is obvious and already known. Of course, it's only a concrete application of a famous principle in developers community, which is the separation of concerns. The second, one more thing, what is nice also is that maybe sometimes the teams that have the expertise for the IT part and the teams that have the expertise for the AI part, they are not in the same place in the organization. So it makes it easier for them to work at their own level. But for the AI part, so if it's developed by more teams with more the AI expertise, should not forget that they should apply some software-based design principles, because otherwise, once again, you could face a problem that your solution is not future-proof. And I propose here a set of principles that is a famous set of principles. It's called solid principles. I'm not going to detail them all, but they guide developers when they try to make applications. And two of them that I find really interesting when you want to consider this characteristic of being future-proof. There is the first one, which is the open-close principle that says that if you want to integrate something new, an extension, a functionality, you should not modify the existing code, but just have to produce new code that plugs to the existing code, but you should not change the existing code. And the dependency inversion principle that states that you should build some abstractions of what you want to be stable in your system and have the low-level details. For instance, if you have one type of model that does that type of details, and you should put that in parts of your applications that don't change the main abstractions that you build. The third principle is a principle I call pipelines are all you need. Why do I like this principle? So what are pipelines? I think you already know. They are those. It's about chaining components that do different things, and pipelines are really adapted to what we do in AI. What does AI? Takes data, process it, outputs new data. So this concept is really adapted, and why I like it, because it's more simple concept to apprehend, to understand than the principles I gave just before, the solid principles. It's something that is more concrete. And if you try to have your AI system implement this principle of pipelines, automatically what I say is that it will help you meet those solid principles that I mentioned before. And a very popular example is the scikit-learn library. I guess everybody knows scikit-learn here in the room. And it's a library that's been here for 10 years, that is recognized by the whole community about the quality of its design. And it relies a lot on this concept of pipelines, which really easily enable you to, for instance, extend with some custom data transformation or external predictive models, and you have libraries such as XGBoost, LightGBM, or the famous libraries that actually very easily propose you to plug those models into some scikit-learn pipelines. You can easily, in one pipeline, change a model by another via just configuration. The user, it just needs to know how to use pipeline components and the specificities of each component it uses, but no more. It doesn't need to know the whole library. And the pipelines, the object of the pipelines and how the pipeline is orchestrated, doesn't need to know what are the exact details of the models, what they do inside, what does XGBoost do, etc. So thanks to this concept of pipelines, you meet all those solid principles that I mentioned before. If you try to do that, this thing that you need to work on, though, is to have the equivalent of a pandas data frame. So what does scikit-learn? It processes NumPy arrays or pandas data frame. If you build an AI system with some pipelines, you need to design the concept of what will be the equivalent of pandas data frame in your case. For instance, in our case for IDP, it was to say what is the object that represents our document and that is going to travel to go through all the components of the pipelines. A fourth principle is that you should not base on a one-size-fits-all paradigms. So it's a bit what I've said before, but we realized in our case of our IDP that business cases have different requirements, okay, in terms of accuracy, latency, and cost trade-offs. Sorry. A back office batch processing of invoices, maybe the operational team, they are okay to have slower models, they can wait longer, and they are happy, they require that they have the most precise results, the most higher accuracy, because we are talking about numbers, we are talking about P&L, you really need something qualitative. Maybe for another use case, you are facing the customer in a claim process, you want to do something real time, and the operational team, they are happy if you automate only maybe 60% of the volume of client interactions, if you can do it really fast. So they can have different trade-offs, and actually you cannot answer to those trade-offs and develop a solution if you only use one paradigm. Because if you use one paradigm, it will have one latency, it will have one accuracy. And so once again, that's where the magic of pipelines come. If your AI team is able, use case by use case, to design that for this use case, we will implement this pipeline that will do that much steps because we need that much accuracy and etc. They can do it. Maybe for another use case, you can say, okay, we can drop many of the steps because we need to go faster. And by the way, the documents, they presented less challenge. And they can go even further and having only one, for instance, end-to-end generative model. The fifth principle is the fact that you should avoid that what I call the training complexity must not lead to production complexity. So I will mention again here the concept, the library of scikit-learn. So as you all know, scikit-learn, what is really nice with this library is that you have the pipelines, of course, but you have the models in them, so you can use one single library to train and do inference with. When you try to build AI systems on other verticals, such as unstructured data, what you face is that usually, if you want to be able to integrate many innovations, you need to use many different frameworks and abstraction layers that come from different things. And so what I advise is really to design, if you design some in-house libraries, one for model training and one for model inference. That way, if you want to evolve fast on model training, different types of models, you never break the second library, which only takes care of inference. You just have to make and this is the one, by the way, you put in production. But the model training library will more easily, with less risk, evolve with the AI innovations. But it is not enough, and the principle, what I call principle 5bis, is that you should rely on agnostic frameworks for model inference. So it's really difficult to build a production environment that will have all those different frameworks, deep learning frameworks, that can fit together and that are compatible. Maybe you will use one deep learning architecture that needs that PyTorch version with that CUDA version, and for another part of the pipeline that you want to use, you need another version because it's not compatible. You can face really complex problems. So the solution is so you create for the model training, possibly different applicative environments, each for one type of models or paradigms you want to be able to integrate in your AI system. But you should export all these models. You should find the portable format that is best fitting your needs. You have several choices, such as ONNX that we are using a lot. You export all your models in those portable formats, and your production applicative environment, it really relies on one of those portable formats, and then you are safe on the production side. So a applying all those principles, what we came up for our IDP in-house made solutions. So actually it's composed of different libraries. We have one library that handles this concept of pipelines. We have libraries that's only dedicated of the models, dedicated to training the models that then once trained we are going to put in the pipelines in a portable format. We have a library that is here to configure a business case and say, okay, for this business case that have that many documents that we need to classify and those exact information we need to extract, what are the pipelines we are going to configure to solve that business case? And we have a serving library for what I told you, for principle 5, so that the applicative environment to have that serving library work is far more less complex than the applicative environment for the training part. And if we have a look on the pipelines library, well, we have to conceptualize this document object that is like a pandas data frame. We have built a concept of processors that process our documents for different steps of the pipeline. We have this concept of pipelines and the serialization of pipelines, making the pipelines in configuration text files that we can use to ship what we worked on in test environment to the production environment. So this is the end of my presentation. I put back again the 5 principles, and I'm open for questions and comments.